Hello, this is the LemnaTec Academy with a key question in plant phenotyping. You have got phenotypic images and now you need to get them analyzed. So how to come from here to there, from a taken image to an analyzed image? Especially if you are not a programmer and there is no programmer available in your working area. So a typical situation. A biologist is doing phenotyping. The biologist records the images and now they should get analyzed. What to do? In the LemnaTec software suite, there is LemnaGrid, and with LemnaGrid also biologists or other non-programmers can work on image analysis programming. Let's have a quick look how it works. So we have taken an image for phenotyping purposes. So we see a plant on a photograph and we want to know the dimensions and the morphology of the plant. So we want to get this. The plant is analyzed. It is separated from the background. It's measured. You know height and width. You know the area. You know some factors about the morphology. To get there, let's start LemnaGrid and launch the LemnaGrid expert. To start programming, we drag devices from the library onto the interface. In addition to the device for opening the image, we take a segmenting device, two filter devices, an object converter device, and an output device. As accessory, we also use a loop-through device. The output device needs a name. We call it plant measurement. This is important to later use the programming for analyzing images. After dragging the devices on the interface, we connect them to tell the devices that data go from one device to the next one. As the output device requires two inputs, the processing and the original image, we use the loop-through device to get the original image to the output. Via opening the input device, we can select an image for processing. The image is loaded. In each device, we can use the F key to get the full image on the screen. As first step of image processing, we do the segmenting process. Opening this device, we can do settings for image segmentation. In the HSV color space, we use the hue value to separate green parts from the background. With values between 20 and 130, we capture the green and avoid most of the background. But there is still a bit of background. This is the reason why we use filters in the next step. Selecting the first filter device, this screen opens and we can start filtering. Shrinking everything by 2 pixels makes small items in the background disappear. We then increase the size by 2 pixels again. Thereby we compensate for the losses at the real object. Now it's nearly clean, but there are some gaps in the plant. We use the next filter to close them. With the fill area filter, we can close gaps in the object and we can remove remaining particles in the background. To do so, we can set the amount of pixels up to which gaps should be filled. Here we try out 50, but we increase it to 100 and now we get rid of the gaps and the background particles. In the next step, we convert the detected plant in the image into an object. The object then can be measured. Finally, we are at the plant measurement output device. We see already that the plant is outlined. We increase the outline and give it a different color to make it more visible. We also mark the convex hull of the object, and we give this line also a color to make it visible. Now the programming is ready. Essentially, that's it. We have programmed an image processing pipeline. And yes, you don't need to be a computer scientist for image processing programming. If you have not one image of one maize plant, but many images of many plants at different developmental stages, you can use this programming to process all of them. You run it across all the images and get the results for all plants. How to do this? Visit our playlist of training videos. There you will get an instruction how it works.